mostly close together or not. Okay. So essentially, like, both of these groups have a mean score of 75. So they have an average score of 75. A standard deviation mostly focuses on the average in the value. Guys, put that away, please. Put them away. I don't want it out at all. Okay. So, which group of scores are closer to the mean? So if you look at these numbers versus those numbers, like, what's closer to the mean? Group A or B?
B. C. C.
B. Okay. So which numbers are closer to the number 75? These ones or that one? Okay, good. Okay. No, 75. Okay, which group shows more variability? So variability is like differences in the numbers. Right, so that'll be B. Or like the other way they'll say it is like further from the mean. Okay. Which group would have a larger standard deviation? So a larger standard deviation means it's further from the mean. So that's why it's B. Okay. So that would be those. Okay. Even more specifically, if the data is normally distributed, which means it's a bell shape, that's usually like how grades are calculated in university, is by a bell curve. You'll hear that. It's a very like popular statistics way to like disperse data. So if it's normally distributed, 68% of the values are within one standard deviation of the mean, and 95% of the data is within two standard deviations. Again, it's like a summary of data, like this number is. So like 60, I know this seems like random, this 68%. But that's one standard deviation, and then 95% is two standard deviations. So these questions are actually, if you know what to do, they're really easy. So most students, so when they say most, on the test, they'll say about like 68%. They'll say either most students or 68% of students score between. So if we have the mean of 80 and a standard deviation of 5, this is literally all you do. You take the mean, 80, and if it's 68%, that means it's one standard deviation from the mean. So all you do is subtract 5 and add 5. So this one standard deviation, most students, 68% of students score between a 75 and an 85, if you know the mean, okay? Almost all students, so they'll say like almost all, that's like code for 95%, okay? So that's almost all students score between, well, if my mean is 80 and my standard deviation is 5, 95% are within two standard deviations. So you're literally doing 80, not minus 5, but minus 2 of them, 10. So the standard deviation changes, like they'll say it's like 2 or whatever. You just add that number or subtract that number to the average. That's all you do. So it's not horrible. It's just you have to remember what that means, So that can be hard. So, all right. So this is where you might have a meltdown, but we'll see how it goes. Okay. Look at that formula. Woo! It's fun. Okay. So standard deviation is this beast of a formula. Okay. Whoa. That's weird. Okay. So I'm going to show you 2 ways to do this. Okay. Guys, stop talking, please. I'm going to show you 2 ways to do this, okay? That little symbol means it's a Greek letter. So these are little fun facts. It means sigma. Okay? So fun time. It's a Greek letter, okay? The other way you can write this formula, okay, is this also is the same name, sigma, which is kind of annoying, but that's okay. You can do you can rewrite it like this. Okay. I personally like it this way versus like the times 1/n thing, but that's me. So it's the same formula. They're just, think of it as like, instead of multiplying by a half, they're dividing by 2. It's the same like idea. Okay. This means mu, if you're curious, that little u thingy. But that's a formula. So in stats, they have all these Greek letters and stuff. So you just kind of accept it as how it is. Yeah.
There's no other way we can go about this.
No, I'm going to show you how it works. So this is what you do, okay? This mu, it's called, is the mean. That's the letter they use for mean in stats, okay? And it's called mu. So this x sub I, these are all the points that you're going to use, the data points you're going to use. And this sigma thing means adding, okay? So I know this like looks terrifying, but like it's really not bad when you're like actually doing the problem. So what I'm going to do is the first way I'm going to do it is to do like each step separately with the formula, okay? So the first thing you need to do in either case is you need to find the mean. So the mean is that mu thing, okay? So the first thing is you're going to find the mu. Okay, I know it's so weird, but you're going to find the mean between the numbers. So you're going to go 30 plus 45 plus 60 plus 40 plus 25, and then there are 5 of them, so you're going to divide by 5. Okay, so you're going to add them all up. You get 200 when you do that. Divide by 5, right? So we get 40. So the average is 40. Okay, that number, okay, goes in this spot. Okay, so this is the mean, is that mu thing. Okay, this n thing, guys, write this down because you're gonna need this for, is actually, I might keep that as purple. N is the number of terms. So this is gonna be like the number of like data points, you know, like it's going to be 5, right? Because there's 5 numbers, or like the number of numbers or something, however you'll remember it, write that. Okay. So it's like the number of data points, the number of numbers. I don't know if that makes it more confusing, but whatever. Okay. So now what you're going to do is you're going to figure out, you're going to take like this mean and subtract it from each of these terms. So this thing right here is I'm going to go 40 minus 30. Then I'm going to go 45 minus 40, 60 minus 40, 40 minus 40, 40 minus 25. I'm going to take the difference between the mean and each point or each data point. Okay, so I'll show that all in a sec. So the next thing you're going to do is you're going to take like just the difference. It doesn't matter like which one you do first, because you're honestly going to end up squaring these later. So I always just do the bigger one minus the smaller one just to make things easier. So like this first number is going to be 10. Then you're going to do 45 minus 40. So you're just taking the difference between all the mean with the mean. So this one's 5. I mean, I know you guys can do this in your head, but just write it in your notes so you remember where all these numbers are coming from. 40. Like this step I usually do in my head, to be honest. I'll just be like, oh, subtract each time. And then especially this one, 40 minus 40, like that's like, yeah, 0, duh, right? And then I do 40 minus 25. So I'm just finding like how far away is each number from the mean. That's like what I'm doing, the differences, okay? So I have 10, 5, 20, 0, and 15. So I subtract all those. Is everyone good so far? Okay. Now what you're going to do is you're going to square each of these. Okay. So what we just did, that step 2, is we figured out this difference right now. Okay. So what we did is we did this right away. So now what I'm going to do is I'm going to square each of the numbers. Okay. So in step 2, I figured out this subtracting thing. Now, following the formula, I'm going to do the squaring. So you could follow these same steps every time. You'll be given the formula. You don't have to memorize it at all. So just so you know, but like you're going to square all these. So you're going to go like 10 squared. Again, I would do this in my head, but like just because it's your notes, you want to remember where the numbers are coming from. And then I would do 20 squared. And then I would do 0 squared, which feels dumb, but that's okay. 15 squared. And you would get all the numbers. Okay. Now what I'm going to do, so that sigma thing, that like, that weird like S looking thing, sideways M, this is sigma. This means you're going to add all of those up. So this is just a fancy symbol to represent that you're adding them all up. So your fourth step is you're going to add them. Okay. So you're going to take 125 and 400 and 0 and 25, and you're going to add them. Okay.
225.
And 225. Thank you. Oh my gosh, that would have been so annoying if I didn't write that. That would have been so bad. Okay. So bad. Okay. And divide by 5 because there's 5 numbers. So I'm adding them all up and dividing by that n. Okay. So I'm adding them all up and dividing by the n. So that's what I did in the blue part. So I'm like adding them all up, dividing by the n. Okay. Now you add them all up, divide by 5, and you get a ripe old number of 150. Okay. And the standard deviation of that is when you square root it. So you're going to square root 150. So you get about 12.2 for your answer. So again, you could do each of these steps just like this. Like, okay, mean, subtract them all, square them all, then average them, then square root. So I don't know if that makes it harder or not. Okay. Or you can go ahead and plug it in the formula. So I'm going to show you that with this example. So it's a different kind of vibe. Okay. So the first thing with this other one, so again, different way, you don't have to do it this way, it's just a different way, okay, is you need to first figure out the mean. So it's always finding the mean first. So the mean or the average or this mu thing is where you add them all up and then divide by, oh, it's 5 again. Okay. So you're going to add them all up, divide by 5. So I get 20 over 5, so I get 4. Okay. So I get 4. Now, this is one way you can do this. You don't have to. But to find the standard deviation, what I can do is do it all at once. So I'm going to have like a psycho huge square root. Okay. And what I'm going to do is I'm going to take the difference between the mean and all the numbers. So I'm going to do, here, I want to keep with my colors that I'm doing this with. So I'm going to take the difference between, guys, stop, all the terms and the mean. So again, this might be a little bit more terrifying to do it this way. I don't know. So I'm going to go the mean minus 2. I'm going to do the mean minus 4 because I'm just going down the line of the numbers. I'm going to do the mean minus 3. Okay. I could do the mean. Well, I'm not going to do the mean first because I'm going to avoid the negatives. I'm going to go 5 minus 4. Or wait, shoot, I messed up the colors. This would be 5 minus the mean 4. And then this one would be 6 minus the mean 4. So that's the second step, is when I'm like dividing or like subtracting them all. Okay. So that was step 2. Remember when we did all those numbers? Then notice that I'm going to have to square them all. Okay. So if I set this all up all at once, again, you're going to square them all. Okay. That's the squaring. And then you're going to add them all together, all the squared stuff, and divide by 5. So the last step is you're going to add them all together and divide by 5 because that's how many terms there are. So I don't know what your brain likes better because that formula looks terrifying maybe to some of you, but it's all in one step, okay? So again, the steps for this, you find the mean, you take the difference between all the terms. So you can go ahead and do that in your head. Like I would just be like, oh, the difference between 4 and 2 is 2. 4 and 4 is 0. 3 and 4 is 1. 5 and 4 is 1. 6 and 4 is 2. Okay? Then you're going to square them all. Okay? Add them up and divide by how many numbers there are. So there are 5 numbers. That's where the 5 comes from. It's not always 5. Like 5 numbers. Okay? So when you're solving this, okay, what you're doing, which I don't know if this is more annoying, it's like you're doing 2 squared plus 0 squared plus 1 squared plus 1 squared plus 2 squared. So I did this subtracting with all of it. You know? Now I'm going to like square all the numbers. So then I get 4 and, I mean, you can write 0, but that feels pointless to me, but you can write it. Plus 1 plus 1 plus 4, all divided by 5. So now I'm just simplifying it. Okay? Then you're going to add the numbers together. So 4 plus 1 plus 1 plus 4 is 10. Oh, whoops. I was doing it in my head. Okay. Divide by 5. So you would type in the square root of 2 in your calculator. So it'd be about 1.4. That would be your standard deviation.
And if you want to round it to the nearest one.
Tenth. Yeah, 1 decimal. Okay. So I don't know which one makes you feel better. Just do whatever works for you. Okay.
Come back here.
All right. So that's it. I'll get you the worksheet in a sec.